Right. Okay, so now we're in the last section, the last chapters of the metal section. Okay, it is about application and processing of metals, and in this 1 hour, I'll try to explain a lot about application of metals. Okay, what you need to learn is actually it is good. Is a very good knowledge for you if you know a kind or the typical of metals and what is the application of that one. It is quite extensive chapters, and I don't ask you to remember all of them, but at least we understand the basics. Details of the metals and what is the advantages of this metal or what is the drawback of this metal, for example, about that one. Okay, so we're gonna talk about ferrous alloys. Okay, so the metals usually what happen in the reality or in the application usually in the forms of alloys. Okay, so remember that if you have alloys, if you have solid solution, you can enhance the properties. You can increase, for example, the corrosion resistance. There's a valuable properties that you can get if you have alloys. Give me 1 second. Okay, so if you have so the alloys actually divided into ferrous metals. Wait. Sorry. Give me 1 second. Another second. Okay, there are ferrous alloys and non-ferrous alloys. Okay, so ferrous alloys is the alloys that base from iron. Okay, and the iron itself, so the metal alloys is divided into non-ferrous and ferrous. The ferrous itself is for the iron and steel. Okay, so remember the difference between cast iron and steel. So usually the if we go back to the phase diagram, the cast iron usually has around let me write it here. Okay, so it's the cast iron usually that's around 3 to 5% of steel, of carbon in the steel, and while the steel have a quite low percentage of carbon, usually in the around that high the eutectoid points, yeah, around 0.76, and then maybe below that is called hypoeutectoid, for example 0.2, and then higher than 0.76 is considered as a hypereutectoid steel. Okay, so here and the steel itself, and then we know that how to get from the cast iron to the steel. We call it steel making, or where we reduce the amount of carbon by doing the oxidation with oxygen gas. Okay, so and the steel itself, it actually divided into the low alloy. Low alloy is actually for the remaining alloy is very small, so this only contain carbons and then just small amount of alloy, or high alloy. Okay, so high alloy means that they quite has a high composition of other alloy. For example, with the stainless steel has chrome and nickel and molybdenum and vanadium and something like that. Okay, and for low alloy itself, it's divided into low carbon, okay, and then medium carbon and high carbon. And you remember, of course, how that the influence of carbon. Okay, as long when you have a higher carbon content here, what you have with the properties, you have an increasing of the properties, or it's gonna become stronger and harder. Okay, so that's why in the low carbon steel there is a plain carbon steel, or it is actually quite ductile. Yeah, it's quite soft, it's quite ductile. But if you want to have a high strength low alloy, sometimes we have some another additional alloy, and then it's quite high strength. And for medium carbon, it's a plain, and then also there's a heat treatable, and then for a high carbon itself, we divide it into plain carbon, and then tool, and then also stainless. Okay, so and then let's discuss one by one. Okay, so the low carbon steel usually it less 0.25% of carbon, and then it's because it's very below this one here, so it is unresponsive to heat treatments. Okay, because it's very small carbon, so it's very hard to maybe to form martensite. Okay, remember, if you want to form martensite, there should be substantial amount of cementite, and it's very small to form martensite. So how to increase the strength, or to do the strengthening, is actually accomplished by cold work. Okay, remember how we can increase the strengthening? Remember what there are three types how to strengthen the metal. The first one is reduce grains. Okay, so we reduce the grains, or mengurangi ukuran butir. Okay, the second one is to the grain size. The second one, the strengthening of metal, is by adding solid solution, or that means if we add alloys. Okay, so if we add alloying, we may make a different type of steel. Okay, and then the last one is by cold work, or pengerasan dengan tegangan, or strengthening by or we call it strain hardening. Yeah, or strain hardening. So because the low carbon steel is quite ductile, the strengthening is accomplished by cold work. Okay, the alloys are soft and weak, but it has outstanding ductility and toughness, and it's a very least expensive to produce, so it's very cheap compared to others. And then they can be machinable, can be machined and weldable, and then of all steel are the least expensive to produce. So it is very, so we call it plain carbon steel. It is very common for the tank, yeah, for the body of the tank, for the storage, for heat exchanger, or for the column, for the outside of the column. It's very common. The second one is a high strength low alloy steel, so it's also low carbon, but it has been added with some another alloying element. Okay, for example, copper, vanadium, nickel, molybdenum, with the concentration up to 10%. So it's high strength low alloy steel. It may be strengthened by heat treatment. It can be heated for annealing and so on. And then they are ductile, and then there can be formed, and it also can be machinable. Okay, so this is the low carbon steel. This is the typical carbon steel. We can see here that there are the names. So this became AISI, or American Iron and Steel Institute, or SAE, Society for Automotive Engineering, or a STM number, the American Society for Testing Materials. Okay, usually we can see the tensile strength, the yield strength, and the ductility, which is measured in a percentage of elongation in 50 millimeter. Okay, so we can see that the typical application, it can, so for I remember that this one is actually tells you about 0.10. I only know that one. It's quite plain, and this is 0.20%. So it's quite very low, and then relatively low carbon steel. It can be used for panel, for wires, nails. Yeah, it can be for piping, for structural steel, and then low temperature pressure vessel. And then this one is for the truck frame, railway cars, and so on. So it can be used for that one. Okay, so this is it can be used for the bridges, for the heat exchanger, for ultra high form steel. Yeah, this one here, and then also for this called a rivet or baja, yeah, the bridge structure. Okay, and then this one is the typical alloy for oil quench and tempered plain carbon and alloy steel. You can see some other AISSI number as well, or UNS, Universal Numbering System. Here it can be used for relatively, I think it's relatively medium or high. It can be for hammers, can be bolt, knife, a spring, bushing, shaft, and so on. Okay, and this one is for the medium steel. Okay, so the medium carbon or the high carbon steel, it can be for tool steel, ya, buat peralatan, so for equipment, so for drill, for saw, for punches, yeah, for blades, a cutter, blacksmith tools, it can be used for that one. So it added some chrome and nickel a little bit to for the corrosion resistance, yeah, and also molybdenum. This one is a tungsten and also vanadium. Okay, and then this is the piston and the spring, yeah. Okay, the bushing, and then all the machinery, blades and hammers and something like that. So if we have a quite load, we have load and it's quite strong, then we can use a medium or high steel. Okay, this is a picture for blacksmith tools, yeah, like a pipe clamp, quick clamp, steel measure, and so on. So you can just see that one. Okay, so the difference, usually when we buy something, when we buy the equipment, of course it can be the difference maybe from the type of the tools. Okay, I once went to toko bangunan, ya, because I want to have a repair my house, and then outside the shop, there is like maybe seller, yeah, penjual, and then they just sell hammer or blade, something like that. It's very it is actually very cheap, like maybe like 50.000 or something. Okay, but when I see it's actually why it's very cheap, I think it's because of the type of the steel. Maybe it's only using plain carbon steel and it's not really good enough. So if you want to have maybe with the good good quality, I think of course the price would be different, yeah. So again, it depends on the type of the alloys. Okay, it's quite long explanation, but actually for the medium carbon steel, you can see around here, yeah. So it's really between steel about, it's called categorized as hypoeutectoid steel. Remember, the eutectoid is 0.76. It can be used for railway wheels, gear, crankshaft, and then it has a high strength and wear resistance. High carbon steel is used very strong. The highest one up to 1.5, for example, would be for knife, for razor, for the application for medical, maybe for knife, yeah, pisau bedah, and high strength wire. So again, it depends between the low carbon steel, medium carbon steel, or high carbon steel. It based on the application. Okay, and then the last one for the steels, carbon steel, is stainless steel. So the stainless steel has chrome almost 11 weight% of chrome. So the chrome is actually will make layers of Cr2O3 on the surface of those metals. Okay, so if you have stainless steel, it is highly resistant rusting, usually on ambient atmosphere. So if you put it maybe in some cases, if you put stainless steel on maybe a humid condition or very strong acid, sometimes it's still broken too. So stainless steel doesn't mean it really no stain at all, but it's got quite stainless, that one there. Okay, and then we also add nickel and molybdenum to increase the concentration. Okay, stainless steel, the students usually like to use stainless steel as the material of construction if they design distillation column, for example. But remember, stainless steel price is 6 times of plain carbon steel. Okay, so be smart when you put stainless steel. If you think stainless steel is a very good, it is really appropriate, and then you get good advantages from that, use stainless steel. But if not, if it is okay with plain carbon steel, you can use plain carbon steel. Usually for the stainless steel is all the cooking, cooking pan, or if you want to boil something for the food industry, yeah, pabrik pangan, they all need to use stainless steel. Okay, so this is so the stainless steel, they have some microstructure. There's austenitic, so looks like austenite, and it looks like a ferritic, and also martensitic, and precipitation hardenable stainless steel. So we can see here there's a number that the one that we look at much more is stainless steel 304 and 316L. Okay, so it is quite strong, yeah, relatively strong than plain carbon steel. It can be used for welding, construction, for chemical and food equipment, can be cryogenic vessel, can be for valve, automotive, and cutlery. Yeah? Once when I was in Australia, I saw that there's like cutlery or like spoon and fork, but just so expensive, like I don't know, maybe $100 for just one set. I think that's because if you use stainless steel, then it is very shiny and then strong, and then it can last like forever. Okay, so this is called martensitic and so on. Yeah, the stainless steel. Okay, and then this is some application for turbine blades, or this is for welding. Yeah, if you know what is welding, so this is they join them together and before welding, and this is for the turbine blades. You can use as well. Okay, so that is the this steel. So you see that I know that there are a number of the type, okay, composition, and this is the condition. Yeah. So what you need to learn later on is you have to be able to read these tables, and then where to get the information. For example, how is the tensile strength then you need, or do you need the yield strength, or do you need the ductility from that one. Yeah. Of course, I'm not asking you to remember all of it. Okay, maybe our friends in mechanical engineering or in material engineering, they need that one because they're used to dealing that with this material every day. Okay, but for us, at least we need to know all the types, and then what is the typical application. So when later on you need to buy something, and then you see the application, you know is it the right one or not. Okay. So that one. Okay, so the next one is the cast iron. The cast iron, it is divided into gray iron, ductile, white iron, malleable, and compacted graphite iron. And because it is a very hard and very strong, so you can't roll it. Okay, so it can't be rolled. So what you need to do is you just need to do the casting. Harus dicetak. You have to melt it, harus dilelehkan, and then you just need to cast it, yeah, in the casting. Okay, so for example, for cast iron pan, yes, cast iron pan is really popular in the kitchen. It is good for making steak something. This is for crankshaft in the machineries, for jaw crusher liners. Yeah, jaw crusher is the one to crush rocks, the mineral rocks. So they have to like crushing the rocks. It can be for sizing grades or roller crusher if you need. So very hard and wear resistant, harus tahan aus, keras dan harus tahan aus. Okay, for impeller, for ball mill liners and mining crusher and so on. Okay, so in the cast iron lies around here, and it's actually, even though that we know that this is alpha and cementite, the cementite is unstable. So in a higher carbon, usually the cementite will change into alpha iron, yeah, and plus the carbon. Okay, so this is the true equilibrium iron and carbon phase. Instead of graphite instead of cementite as the stable phase. So here at lower temperature you get alpha and graphite, and around high temperature you have austenite and graphite. Okay, so what happens is, if you look at the iron, in the iron they have those flaky carbon. So this is the carbon, and this is the alpha. Okay, it can be divided into gray iron, nodular iron, white iron, malleable iron, and compact graphite iron. To predict the properties, you can see also the boundary area. Okay, luas batas fasa. So for example, if this one, the luas batas fasa, yeah, or the interfacial area between the graphite and the alpha, then it becomes stronger. Okay, if this is one is the interfacial area here, it become a ductile. So it is actually quite ductile, the nodular iron, and then this is quite strong. Yeah, this is one also quite strong. Okay, so here, so from iron and carbon phase diagram, this is the composition range for commercial cast iron. Also schematic microstructure that results from variety of heat treatment. So GF is the flake graphite, graphosite, graphic nodule, perlite, and ferrite. So here some of the what we call the microstructure. This is called white iron if we cooling with the fast cooling. This moderate, we can have a paralytic gray cast iron, and if slow cooling, we have a ferritic gray cast iron. Yeah, this is just some explanation about the microstructure of the cast iron. Okay, so for the cast iron, because it is can be only for casting, hanya bisa dicetak. So you can see from the matrix microstructure about ferrite and perlite here. The tensile strength is it depends, yeah, it's relatively similar to the steel, but sometimes it's harder, up to 800. So it is used for diesel engine blocks, brake discs for high-speed trains, or diesel casting, yeah, cylindrical blocks, and transmission scratches and so on. Okay, so for gears and machine, and then when we make it, it just need to be cast, harus dicetak. Okay, so for example, when they do this one, they will prepare a casting mold, ada cetakannya, yeah, and then they will pour the melted metal to here, and then to let them to set maybe in fast, middle, or cooling. Okay, up to here, any question maybe about iron and steel? No? Okay, so it's quite new things to learn, but that's alright, of course, because so at least we know what is the difference between iron and steel, and then cast iron and steel, and then all the typical application. Okay, even in few years ago, I had a bone tumor on my left hand, so here, yeah. So it is the doctor said it has to be removed because it is cancerous. So around 2019, yeah, I had undergo some operation, and before the operation the doctor tell me what to do with my left arm, and then he give to me the show to me the, so there is a implant like a long road, yeah, batang panjang, yeah, with some yeah, like a he said it made from stainless steel from 316, yeah, from this one. I said, oh my, doctor, I'm also a lecturer in engineering material, so I check everything, but the material is actually has been certified with the Kementerian Kesehatan, yeah, for that one, so it can be for implant purposes. So now my left arm is changed with maybe around 20 centimeters, so there is no bone at all, but it changed with the long 316 steel, and then it added as also with titanium with that one, and then there's some screw for that one, so I still can function properly. Okay, so it is good for me, of course. I still can do things that I like. I still can, even I can have I still can ride bicycle because of, but the problem is the steel is very what's called berat, yeah, it's called heavyweight, so I can't lift my hands up. So if I want to lift my left hand, I need to like bring with my right hand, that one. Yeah, this one example here, and then it is 3 years on, so yeah, 3 years on, so everything looks perfect, so I couldn't be more thankful for the doctor to do that. All right, let's continue. The second one. Okay, so now we're going to know about non-ferrous alloys. So you can see all around you, and then how that there's alloys that around you that can affect your day-to-day daily life. Okay, so the advancement and the technology advancement about the alloys is actually will determine the success of a country, of a peradaban budaya suatu bangsa, okay, of a nation. Okay, so because here up to here you have we have so many alloys, so we can actually have a number of application, and it will increase our quality of life. Okay, so the first alloys, iron and cast iron and steel, and the second one is non-ferrous alloys. So let's start with aluminum. Let's start with copper first. Yeah, so this is copper. Let's start with this one first. You can find copper on a pipe, you can maybe look at on hot water pipe. Once when I was in apartment in Melbourne, they use the copper wire, a copper pipe for that one, so I know that one. And then another one is brass, kuningan, yeah, that one is brass. So and then copper we use a lot for wires, for electrical wires, because it has a very high thermal conductivity. And then you have bronze, perunggu, yeah, the one it's used for medals, bronze medal, so you can see this one here. And then there's aluminum, and then there's nickel, silver. Okay, so let's check copper. Copper is ductile, soft. It has unlimited capacity for cold work. It's difficult to machine, so it's susah dipotong, ya. And has a high resistant corrosion environment. And in chemical engineering, we use copper a lot for seawater pump, for seawater piping, for example, or industrial chemicals, or for example heat transfer. And then if you remember about the phase diagram, the very complex phase diagram that looks like a dinosaur, a few weeks ago in the phase diagram, we have some common copper alloy, which is brass, kuningan, and it has 35% of zinc. Okay, it has a FCC crystal structure, and then the brass is relatively soft, ductile, and easily cold work. Okay, and then bronze, it can be added by titanium, aluminum, silicon, and nickel. You can see bronze for the medal, for the Olympic medals, and there's also beryllium copper, has a high tensile strength, very compared to uh, 400 for steel. So it is quite almost 3 times, yet more than 3 times. Alright, and then so this is the copper. You can see here the application of copper. So usually we only calculate the remaining alloys, okay, and then the remaining should be the copper. For example, the brass is this one, zinc with 29% of zinc. This is copper nickel, 30% zinc. I did it, okay. And then, for example, brass, it contains 30% of zinc. And then you can see that the electrical wire, rivets, and so on, yeah, from here. Okay, and then the next one is aluminum. Aluminum is low density. So if we check the iron, is around 8.7, I think, or sorry, about 7.8 gram per cubic centimeter. Okay, while the aluminum it has low density. So that's why aluminum is called light metal, because when we buy something, for example, I want to buy a material for my tank. Okay, what we calculate is actually the volume. Okay, the volume of the tank. Okay, like the area, and then multiply with the thickness of the tank, and then we can calculate how much the mass that, or the volume that we need. Okay, and after that we have to divide it with the density to get. So usually we have the volume. So for example, tank, yeah, we calculate the volume of tank, and then we divide with density, with rho, and then so we can get the mass. Okay, so if we have no, not the volume, not divided, but it should be multiplier. Yeah, so we need to obtain the mass. So the mass is actually the volume multiplied with rho. So if you have some typical of volume, and then it divides with the aluminum and then also the iron, you need less mass that you need, and then less mass of you pay. But of course, later on the mass will be multiplied with the unit cost. So later on, if you consider the economic reason, later on you need to check about the cost as well. Okay, so the aluminum has a FCC crystal structure, and then the ductility will be retained even at low temperature. So it's really suitable for cryogenic purposes. Okay, so for example, you have cryogenic distillation to separate methane and propane and butane, for example, at low temperature, at a cryogenic temperature. Then you need to use aluminum compared to plain carbon steel, because in carbon steel they have those ductile to brittle transition at low temperature. Okay, and then the recent attention has been given to alloys of aluminum and other metals, magnesium and titanium, as engineering material for transportation to the effect reduction for fuel consumption. Okay, so this one is called the light metals. This was my dissertation at Swinburne University in Australia 12 years ago, about production of magnesium. And then with the aluminum and the titanium, they make as a light metal. So if you it is actually used a lot in European car, for Volkswagen, for example, for our Audi. They use that for the frame, for rangka, yeah, for the body of the car, so they can reduce the car's weight significantly, so they can have a reduction in fuel consumption. Okay, and then the effectiveness of this material is high specific strength. So specific strength is actually the tensile strength divided by specific gravity of this one. So it is very good light metals, but later on, if you're interested, you can in my other course, electric course, yeah, fundamental of process metallurgy, I also explain why these metals is very expensive because of the extensive cost for production compared to iron. Okay, and then this is some description: the tempering, strain hardened temper and heat treating temper, like annealed, strain hardened, and so on. Later on, we're gonna learn that in the processing section tomorrow. Okay, so this is a typical several of aluminum alloy. It can be used for food and chemical handling, can be for cooking utensil, even for aluminum foil. Okay, so the aluminum foil that we use if we buy food or we want to wrap some food is also from aluminum, because that aluminum can be rolled into a very, very thin layers of aluminum. Okay, this is the aluminum application. I think it is for you to just see what is the application looks like. It can be for the wheel, and then for the automotive frame like this, for the toothpaste, for the pan, for a can, aluminum can, even for doors. Even now my house use all of them from aluminum because it is very lightweight and it's strong, and then I think anti rayap, yeah, like termite free, or even for this jar. Okay, another one is magnesium. So it was my dissertation, how to produce magnesium. It's even lower density compared to aluminum. So it's only 2/3 of aluminum and 1/6 of steel. So it's very low structural metals. And then it is used in where the lightweight is important consideration, for example, for aircraft component. When I studied this magnesium, even in 1940s in America, they have been developed because they want to make a very lightweight aircraft for the World War II. And after that, it is start growing, and now the Chinese is the major producer of magnesium alloys. Okay, but chemically, the magnesium is relatively unstable, and if you have a magnesium powder, it's actually the raw material for fireworks. Yeah, it ignites easily, so it is used in fireworks. So there's some safety issue with if you're handling with some magnesium pieces or powders. Okay, and then this is the some common of magnesium alloys, AZ31B, like with some little bit aluminum, zinc and manganese, used for tubing, for cathodic protection, and so on, for die casting as well. Okay, and then this is the magnesium application. It can be for hanger beam, for steering wheel, for the body of the car, okay, for the cylinder head, and so on. So the seat frame or inner frame, it can be used that one. And then the titanium, one more, yeah, the titanium. It is with the light metals, is also very, very strong, and then it also quite low density compared to steel, so it's still considered with light metals. Okay, it is used for airplane structure, space vehicle, and surgical implants. So if we go back to here with the titanium application, common titanium hip joint, yeah. So usually in in the developed country or maybe Indonesia as well. So because people live longer, up to 80 years old, 90 years old, or sometimes 100 years old, around that time there's something happen with the joints. So even all the medical insurance cover, we call titanium hip joints. Or even, for example, I know that few years ago, Andy Murray, do you know the tennis player from British? He has surgery about titanium hip joint. So the hip, yeah, pinggul, panggul, it is actually changed with the titanium joint. And this one is for implant as well. Even I have one kind of this in here. So it is to join the steel rod and also my bone. So they connect them with some screw and then some plate like this in my inside in my left arm. And it can be for our dental implant. If you have a dental implant, or if your mom dad has a dental implant, to for this here. And also golf club or titanium turbine blades. Okay, so looks like, okay, 10 minutes. And then nickel alloys. Nickel alloys has a good corrosion resistance in a basic environment. For example, stress corrosion cracking. So, and also pitting. Pitting is a type of corrosion. So if you have a permukaan, ya, or the surface, and then there's a crack over here, and then you have some water, and then the water stay over here, what happened is there would be a corrosion. So from outside it looks like just like tiny dot over there, but then from if you slide it up, it goes down there, and it's very deep, and then it's very bad. So pitting is a very bad corrosion for steel. Okay, and then nickel alloys actually can have a good resistance for pitting, so it can prevent pitting. The second one is stress corrosion cracking. So if you have a cracking, if you have let's say if you have a crack, for example, and also you have a pressure load of your body, of your there is a pembebanan, yeah, there is a load, something like that, it's gonna be prone to corrosion. So it's just gonna be very easy to corrode, and then after that it will make the metal will go failure. Okay, so this is some type of nickel alloys, like incolloys. It contain nickel, inconel, or that one. But and with the other type of alloys, it's called super alloys, and super alloys very expensive. Okay, so that one, the super alloys, is very superlative combination properties used for aircraft turbine components and semuanya, but very good properties. Okay, another one is refractory metal. Maybe just some other things. So refractory metal, for example, molybdenum, tungsten, maybe the very I think good application is for lampu, for the lampu pijar, ya. The wire inside the lamp is actually from tungsten, and then it's classified as refractory metal. Okay, so later on you can have a look on this handout, or in the book as well. You can try read it and then try to imagine what is the your application all around you. Okay, and then maybe I think just few. The last one is the noble metal. For example, iron or gold, silver, and so on is just used for jewelry. And then platinum, palladium, rhodium, it can be used also for catalyst or from something like that. Yeah, that one there. And then lead and tin, it is used for solder. Yeah. And then another one is, last one is the galvanized steel. It is iron with zinc. Okay, it can be used for plumbing fixture, automotive part, and office equipment. Okay, so it is quick, but with those application, I think I would like you to maybe have a look around you. For example, you have a phone maybe from aluminum frame, or you have I don't know, maybe you can see a lot of aluminum here, yeah, or maybe from your roof is from galvanized steel and so on. And then yeah, at least you know what happened around you. Okay, so this is an example bahasa Indonesian latihan. For example, why the iron based alloys is used a lot. Okay, and then maybe you can explain the basic structure of the cast iron and so on. Alright everyone, so I think that's conclude our application of metal. So have a look, just try to enjoy the while you have so many applications, but at least you can see all around you. So what is your bicycle made from, or your motorbike, or the kitchen utensils. Okay, so at least it is good for you to understand. Tomorrow we will have maybe 1 hour to do but processing, so at least you know what is the difference between cold working, forging, die casting, and so on, and annealing and normalizing, something like that. And then maybe about 1 hour to we will discuss some examples, okay, of problems. Alright everyone, thank you very much for your attention. So I need to conclude this lecture, and then I'm see you again tomorrow.